Hi, how are you? I'm Lluís Galbany. I'm a Ramon y Cajal Fellow at the Institute of Space Sciences in Barcelona. And well, I would like to thank the organization here for letting me talk about this project. Long title, short acronym, host flows. And this is because both the NOT and some of the Nordic community are very involved, play an important role in this project. Yeah. Okay, this is a Spanish nationally funded project, 3 years, plus some other funding from the Spanish Research Council for fostering collaboration with international institutions, one of them being the Horus University. The project basically is divided in these two big blocks. The first one, which is called H-Not Systematics, is basically a lot of studies, supernova sea fate with a lot of techniques, photometry, spectroscopy, and polarimetry, with a deep study on extinction and environments to study systematics of H-Not measurements. I'm not going to talk about this today. And the second block is Cosmography of Laniakea. It's basically reconstructing the dark matter distribution in the local universe with observations of type 1a supernova in the near infrared. These are the suspects that are involved in the project: 2 postdocs, 4 PhD students, plus 1 waiting for another one. These 3 people working in this block, some of them here, Thomas, Kima, and Dane, work on this Cosmography of Laniakea block. Yeah, there was a joke with the Danish flag. This guy is Danish. That's why, yeah, I learned the flag everywhere. We are not alone. We are a big collaboration, quite, middle-sized collaboration, I would say. Here you see ourselves in Barcelona. And here in green, I put collaborators from Horus. You have here Emir, who have just talked, Claudia, and Max as well online. People from Hawaii, from Portugal, Chile, Carnegie Institution, Cádiz, and Clermont-Ferrand. Yeah, I said that. In particular, members from Horus and Turku. Well, the motivation for this part of the project comes from, or builds from, previous work from the Tully et al. Tully collaborators in the Cosmic Flow collaboration, where they use or they measure distances to galaxies, using galaxy scaling relations to measure peculiar velocities of these galaxies in the nearby universe and map the distribution of these dark matter concentrations. The basic idea is that those galaxies are pulled by these concentrations, so then you can, doing some visualization technique, produce a map like this and locate those big concentrations of dark matter. Our goal is to construct of the order of 1,000, a sample of 1,000 near-infrared 1As, or 1As with near-infrared observations, to obtain 1–2% systematic distances in a volume extending up to 0.1 in redshift. With that, we will infer peculiar velocities of the host galaxies, reconstruct the dark matter distribution, as I said. With all this information, we will be able to infer cosmological parameters such as H0, the amplitude of fluctuations, sigma 8, and the growth rate of a structure. With all that, we will be able to test gravity models other than general relativity. Why type 1a supernovae? Because with that, we will be able to map our supercluster Laniakea at farther distances and with more precise distances. Yeah. So these galaxy scaling relations, Tully Fisher and fundamental plane methods, are not very precise up to, well, beyond 0.03, 0.04 in redshift. Here you can see an example. Black dots are from cosmic flows. Green and yellow dots are from Carnegie Supernova Project distances, type 1a supernova. One of the best samples ever observed. Individual distances are more precise than the galaxy scaling relations, basically because in the near infrared, 1As are better standard candles naturally, but also the reddening effects are minimized. On top of that, we will be able to use a new a new template, a new near-infrared template from the Carnegie Supernova project, which will allow us to use the best K corrections ever used for type 1a supernova in the near infrared. And well, I mentioned this before, but we would like to achieve a peculiar velocity measurement or centrality of 300 kilometers per second at our farthest redshift, and this will be we will be able to reach these numbers building a large sample with around 1,000 objects. Yeah, this is just a Hubble residual with, again, comparing distances between the cosmic, the cosmic flows, this galaxy scaling relation distance to type 1a supernova in the near infrared in yellow. Just another example of how well we, hopefully. So we started a new near infrared 1a survey. The idea is to combine optical light curves from ZTF, ATLAS, and TJO, and then obtain 1 to 3 JH epochs with all these facilities. We have been sending proposals, and we have been successful in all this, including here NOTCAM at NOT. This is an example of an object with NOT, 21XMZ, H-band, supernova here. Well, this red color is not very clear. So far, we have obtained already 500 of them. So as I said before, this is a 3-year project. We started in September. We are almost finishing the first, and we are at half of the goal. So right now, this is already the supernova survey with the largest number of supernovae in type 1a supernova in the near infrared, the largest ever built, and we are still going on. The idea is that these feeder surveys, ZTF, ATLAS, and many others, or a few others, discover supernovae. We are part of this transient broker called Alerce in Chile. These brokers, all of them work similarly. They apply machine learning techniques, classification techniques. The best objects are selected, are scored by several, well, depending on your science. And we of course, won 1As. So those that are selected for having the highest score of being a 1A are then triggered in any of the infrastructure or telescopes that we have access to. And this near-infrared point is observed. Then we feed together the optical and the near-infrared, and we put our point in the Hubble diagram. As soon as we reach large numbers, we will be able, for instance, here you see a F sigma 8 plot with all the public measurements at intermediate redshifts, where there is a lack of a measurement at very low redshift. And here, well, you cannot see this. There are several, this is Lambda CDM in blue, but there are several other models here which are very similar at intermediate and high redshift, but they diverge here at low redshift. So then with our measurement, we will be able to reach among models. This is an example. Well, actually, this is a simulation. Thomas Muller, the postdoc at ICE, at ISS, well, have been working on to prove that our experiment is feasible. This is a paper we just submitted to ANA. So here you have a CSP, a Carnegie Supernova Project supernova with a lot of bands, but we will just focus in GR, simulating a ZTF observation, plus J and H, the bands that we are getting with all this infrastructure. So we do the feed all bands, we keep the peaks of all these bands, and then what we do is repeat the feed, but just using one of the points of the observation. We are using CSP as our model. So then you will see that the feed changes as the epoch that you have included in the near infrared changes on the epoch. This is the summary. You cannot see here very well, but there are a lot of lines, of gray lines, all the feeds that we got. And it's clear visually, but I have a summary later, that as soon as you are within a week or two around maximum, you can recover very well the in J and H. This is the summary with all the CSP data. And again, our our bias is about 0, and the sigma, or the uncertainty, the scatter around these epochs of -10 to +15 is less than 0.1 magnitude. Emir just mentioned that. Mostly, I mean, this is thanks to Rasmus Hanberg and Emir at Horus. We have this web page and pipeline set in a server at Horus. We can here very easily, with the front-end web page, upload images there. The pipeline runs automatically in the server and then pop up in the web page with the results. So for each target, we have all the catalogs, the position of the object, the ZTF and ATLAS and other optical data, our near-infrared point, and then all the details for each image. I mean, all the calibration and all the stuff. This is the distribution of our 500 objects. I mentioned that before, that this is a statistical survey, so you want to get how the peculiar velocities per beam are. So then, as many objects as you have there, the most precise is your measurement. So you want to have the objects distributed over the sky. This is just a summary, a plot summary for NOT. So NOT has been contributing so far with about a quarter of the objects. This is the redshift distribution and the magnitude distribution, and this is over time. We have been running for 4 semesters. Yeah, it's not very clear here, but well, you can see these vertical lines, which corresponds to nights. So we have 1 night per month. We have had good weather on average, just lost like 4 nights or so, and there are more coming. Actually, tomorrow night. Yeah, this is all I wanted to talk to you about the project. I just wanted also to mention 2 minutes, excellent. I just wanted to mention to the Nordic community and the NOT, the owners of the telescope, that this project comes with a strong outreach and dissemination program. And besides the typical web page, social network profiles, this is Twitter and Instagram. Well, this is me giving talks at schools. We have this agreement with the Fundació Bofill to go to we have this agreement with a school in a neighborhood that has some problems with the tuition of students. Public talks, a few public talks here and there, but most importantly, we have this Science Meets Art program with this Catalan artist, Joan Garriga, musician, Pau Riba, and Esteve Plantada. Unfortunately, Pau left us this March, but he's still a very important part of this project. And Esteve and Joan, on February, come with us to observe at NOT. We had the best guides possible. Here you could recognize Jonay, Jesus, and Vicky. We were observing for a night, and then the outcome of this project will be a poetry book written by Esteve, and some of these songs will be made songs by Joan. As well, there will be some radio show where professional astronomers are interviewed by artists. So hopefully this will see the light during the next season. So keep tuned, and I will tell the NOT representatives to keep an eye on that. Thank you very much.